Have you ever really stopped to think about what's actually powering our digital world? I mean, everything from the apps you tap on your phone to these huge complex systems running global businesses, it's way more than just the screens and wires we see. Today, we're doing a deep dive into that very backbone, IT infrastructure. Welcome to the deep dive. Our mission today is, well, to pull out the most important insights from a key chapter in Laudon and Laudon's 17th edition of Management Information Systems. We want to help you. Maybe you're a graduate student right here at the Dr. Sampak College of Business. Maybe you're already working in IT, or maybe you're just really curious, get a solid handle on IT infrastructure and, crucially, its role in IT service management.
Yeah, and what's really interesting, I think, is how often we just take this invisible foundation completely for granted. So this deep dive, it isn't just about what IT infrastructure is. It's also about why it's changing so fast and what that means for how you manage systems and really shape your career in this space. Yeah. It's constantly moving.
Absolutely. And hey, if you find this valuable, if we uncover some useful insights together, we'd really appreciate if you'd engage with this deep dive. Share it with your colleagues, your network, and definitely let us know what you think down in the comments. Okay, so let's start peeling back that first layer. When we say IT infrastructure, the first thing that pops into most people's minds is hardware and software. But the sources, they point to something much bigger, maybe even more important. What's that broader view we need?
That's the perfect place to start, because if you only think about the technology components, you're kind of missing the bigger picture. The more accurate way to think about it, and honestly the more valuable way, is that it's service-based. It's not just about the individual pieces, the servers, the code, whatever. It's about the services that all those pieces generate when they work together. Think of it like an ecosystem, right? Where the whole thing is much greater than just the sum of its parts. And it's all geared towards delivering business value. So when we talk services, there's actually quite a suite. Laudon lists 9 essential ones. You've got the obvious ones, like computing services, that's creating the basic digital environment. Then telecommunication services, which is all about connecting people and systems, data, voice, video. And absolutely critical today, data management services, not just storing data, but managing it, analyzing it, making it usable. But it doesn't stop there. You also need application software services, your ERP, CRM, supply chain systems, and the physical side matters too. So physical facilities management services handle installing and looking after the hardware. Then there are the people and policy layers. IT management services for planning and coordinating everything. IT standard services to make sure different systems can actually talk to each other. That's key. IT education services, training employees, getting managers up to speed. And finally, IT research and development services, looking ahead to what's next. What investments make sense down the line?
Wow, okay. That really reframes it. It's not just tech support, it's this whole integrated system of services. So for people aiming to be IT leaders or anyone in IT service management, what's the big takeaway? Does this mean focusing just on, say, processing power is outdated? Or is it just a different way of looking at it?
It's absolutely a more strategic way of looking at it. The big takeaway, the game changer, is that effective IT leadership isn't just about keeping the lights on technologically. It's about orchestrating all these different services to directly support and even drive the business strategy. So for you, building a career in IT service management, understanding this integrated system view is how you move from just supporting the business to actively enabling its success. You become a value creator, not just a cost center. That's the shift.
Okay, this is where, for me, it gets really fascinating. The sources trace this evolution of corporate IT, and it almost feels like we've done a full circle. What can that history tell us about where we're going next?
Yeah, it's quite a journey, and that full circle idea, it's pretty spot on. We started way back, late 50s, with the general-purpose mainframe and mini-computer era. Highly centralized, right? Big machines and special rooms. Then, early 80s, the personal computer era arrived. Power got decentralized, put right onto people's desks. Around 83, the client-server era began, networking those PCs, splitting tasks between clients and servers, more distribution. Then by 92, we entered the enterprise computing era, really focusing on linking all those different systems together across the whole company. And now, since about 2000, we're deep in the cloud and mobile computing era, which, yeah, in a way brings us back towards centralization. But with these massive globally distributed data centers offering services basically on tap, it's centralization, but on a completely different scale and model. And this evolution, it didn't just happen randomly. There are 5 key technology drivers pushing this forward, and they're still super relevant. First, Moore's law in microprocessing power. The doubling of processor power roughly every 2 years. It's relentless. It keeps making new things possible. We're even looking at nanotechnology now for the next leap. Second, the law of mass digital storage. We're creating unbelievable amounts of data, photos, video, sensor data, everything. And the cost to store a gigabyte just keeps plummeting. So we store more, which encourages creating even more data. It's a cycle. Third, Metcalfe's law and network economics. This one's powerful. The value of a network increases exponentially with the number of users. Adding one more person costs very little, but the potential connections and value they bring, huge. That drives network growth. Fourth, declining communications costs in the internet. The sheer drop in the cost of connectivity has fueled the internet's explosion and made things like mobile computing feasible and expected. And fifth, standards and network effects. Think TCP/IP, HTML, common standards that would allow all these different devices and systems to actually work together seamlessly. They create massive network effects.
Okay, so bringing that all together, what does it mean for you listening right now? Whether you're planning your career path or managing IT day to day, these aren't just history lessons, are they? They explain why things are the way they are now and maybe give clues about the future. How should this inform your thinking in IT service management?
That's exactly it. What's really insightful is seeing that pendulum swing from mainframes to PCs back towards the cloud. It highlights this fundamental tension in IT strategy, the constant balancing act between centralized control and standards on one hand and distributed flexibility and innovation on the other. So for you, understanding these drivers means you can anticipate shifts. You see the underlying forces. It allows you to position your organization and, frankly, your own skill set to leverage these changes strategically. It's about being ahead of the curve, not just reacting to it.
Right. So we've got the what IT infrastructure as a service platform and the why these drivers of evolution. Now let's get down to the brass tacks. What are the actual components? And what's happening on the cutting edge, especially with hardware?
Okay, quickly. The sources list 7 major components you've got: computer hardware platforms, operating system platforms, enterprise software applications, data management and storage, networking telecommunications platforms, internet platforms, and importantly, consulting and system integration services, making all those work together smoothly. That's the core challenge and the goal of IT management. Now, drilling down into hardware trends, there are some really impactful ones. First, you absolutely cannot ignore the mobile digital platform. The expectation now is just anytime, anywhere, 24/7 access. Smartphones, tablets, sure, but now also wearable technology. It's booming. Think smartwatches, fitness trackers, even smart glasses. They're moving beyond consumer gadgets into serious business tools, healthcare, logistics, manufacturing. The numbers are kind of staggering. Laudon Laudon projected nearly 1 billion connected wearables by 2021 and a market hitting $150 billion by 2027. It's a fundamental shift, and that trend feeds directly into the next one: consumerization of IT and BYOD. Bring your own device. It used to be that work tech and personal tech were separate worlds. Not anymore. People bring their own powerful smartphones, tablets, laptops, and they want to use them for work. This can boost productivity, definitely employee satisfaction too. But for IT, it's a headache, frankly. How do you manage security? How do you protect corporate data on devices the company doesn't even own? It's a really tricky balancing act.
Yeah, I can imagine. And then there's the one you gave, that great analogy for the kitchen light being on all day. That brings us to virtualization.
Just exactly. For years, companies bought more and more servers because hardware got cheaper, but they often ran at maybe 10–15% capacity, just huge waste. Virtualization flips that. It lets you run multiple virtual machines, each with its own operating system and apps on a single physical server. So instead of 10 servers running at low capacity, maybe you have 1 or 2 running at 80% capacity. Much more efficient. And the benefits are pretty clear. Much higher equipment utilization. You save on data center space, power, cooling. You need fewer physical machines. You can mix older legacy apps with new ones on the same hardware, and management gets way easier because it's centralized. This idea also extends to storage with software-defined storage, SDS, using software to manage storage hardware more flexibly and often using cheaper commodity hardware. Okay, then we hit cloud computing, possibly the biggest disruptor. It's basically IT as a utility, like electricity. You pay for what you consume. Why build a massive data center for peak loads that happen maybe a few days a year? With the cloud, you can scale resources up and down almost instantly. There are 5 defining characteristics. 1, on-demand self-service. Users can get computing resources themselves as needed. 2, ubiquitous network access. You can access from anywhere with standard devices. 3, location-independent resource pooling. You don't know or care exactly where your data is, just that it's accessible and secure. The provider handles the pooling of resources. 4, rapid elasticity. Scale up, scale down quickly. Handles demand spikes perfectly. 5, measured service. You only pay for what you actually use. Changes IT finance from capital expense to operational expense. And cloud services generally fall into 3 main types. Infrastructure as a service, IaaS. This is the basic building block. You get servers, storage, networking from the provider, but you manage the OS and applications. Think Amazon EC2.
Platform as a service, PaaS. The provider manages the infrastructure and gives you the operating systems and tools. You just build and run your applications. Think Google App Engine or Heroku. Software as a service, Sayage. The provider delivers the entire application over the web. You just use it. Think Salesforce, Google Workspace, Microsoft 365. And deployment models vary too. Public clouds like AWS or Azure, owned by providers, shared infrastructure. Great for many things, maybe less so for super sensitive data. Private clouds, built and operated by a single organization, just for their use. More control, higher cost, often for sensitive workloads. Hybrid clouds, using a mix of both. Keep sensitive stuff private, use public for less critical things or bursting capacity. Very common for large companies.
It really sounds like an amazing deal, especially for smaller businesses maybe. But what are the catches? Are there big concerns, particularly for larger organizations?
That's the crucial point. The benefits, especially for small and medium businesses, SMEs, are huge. Lower costs, easy scalability, access to sophisticated tech they couldn't afford otherwise. But yes, larger organizations have legitimate concerns. Big ones are losing direct control over sensitive data, navigating complex regulations and compliance when data is off-premise, and of course reliability. What happens if your cloud provider has an outage? For critical systems, even a few hours of downtime can be disastrous. So you're placing a lot of trust in that provider. And just quickly, a few other hardware trends worth mentioning. Edge computing. This puts computing resources closer to where data is generated or used, reducing latency. Think IoT devices or autonomous vehicles. Green computing focusing on energy efficiency, reducing IT's environmental footprint. Virtualization helps a lot here. It lowers power consumption, which also lowers the total cost of ownership. And finally, high-performance power-saving processors. Things like multi-core processors mean more power and fewer chips, saving energy and cost across everything from phones to data centers.
Right. Understanding all these hardware shifts is just vital, isn't it? It's not just tech specs. It's about seeing the opportunities they create, but also the management challenges, security, integration, costs that come with them. For you in IT service management, these are strategic decisions. Okay, hardware is essential, but it's pretty useless without the software telling it what to do. So what are the key software platforms and trends our sources highlight? How are they changing business and, the careers of people listening?
Definitely. A really significant one is Linux and open source software. The business value proposition is pretty compelling. Often lower cost, obviously, since the software itself is usually free. But also, security can be a major advantage. The idea is, with the source code open for anyone to inspect, potentially thousands of programmers worldwide are reviewing it. So bugs and vulnerabilities tend to get found and fixed faster than with proprietary closed-source software. Think beyond just the Linux OS. Popular examples include the Firefox browser or the OpenOffice productivity suite. Then there's the software that basically built the web as we know it, Java, HTML, and HTML5. Java was revolutionary because it's platform independent. Write once, run anywhere, Windows, Mac, Unix, doesn't matter. It also introduced applets, these small programs for specific tasks. The idea was to avoid bloatware, those huge applications packed with features you never use but that still consume resources. And HTML, the language of web pages, has evolved massively. Early HTML is pretty basic, just text and simple images. It wasn't designed for video, audio, or mobile devices. That's where HTML5 came in. It was a huge leap forward. It allows developers to embed rich multimedia directly into web pages, make them more interactive, and crucially, ensure they work well on smartphones and tablets without needing extra plugins like Flash used to require. This ties into web services and service-oriented architecture, SOA. This is about making it easier for different applications, even from different companies, to communicate and exchange data over the web. Instead of writing custom code every time two systems need to talk, you build reusable services. Like one service might handle credit card processing, and multiple applications can then use that same service. A key technology here is XML, Extensible Markup Language. It provides a standard way to structure and label data so that different systems can understand it, acting like a universal data translator. And just like with hardware, software outsourcing and cloud services, particularly SaaS, software as a service, have become huge. Companies do this for lots of reasons. It can be cheaper, simpler to manage than developing or running software in-house. This applies to buying packaged software, using cloud-based services, or even hiring external firms to build custom applications. SaaS is especially attractive for smaller businesses. You essentially rent the software you need, often on a per-user basis. No big upfront investment, access from anywhere, easy collaboration. Think about online accounting software, CRM systems like Salesforce, project management tools.
But that sounds like it comes with risks too, right? If you're outsourcing critical software functions, you're giving up some control. How companies protect themselves? I guess that's where service level agreements, SLAs, come in. They seem crucial.
Absolutely crucial. You nailed it. The risks are real. Losing control over your data, security vulnerabilities, potential issues with the provider's reliability or scalability, even the risk the provider goes out of business. SLAs are the contractual protection. They spell out exactly what services the provider will deliver, the performance standards they have to meet, uptime guarantees, security protocols, what happens in a disaster, who owns the data, how billing works, how you can terminate the contract. For anyone going into IT management, knowing how to negotiate, manage, and enforce SLAs, that's a core competency now, non-negotiable.
Makes sense. And then things we use every day, mashups and apps. How do they fit into the business software landscape?
Right. So mashups are about taking existing web services or data from different sources and combining them to create something new. Like maybe combining mapping data with real estate listings or social media feeds with news articles. It's about creating added value by mixing existing components. And apps, well, everyone knows apps, small, usually single-purpose programs downloaded onto mobile devices. While many are consumer-focused, there's a huge and growing market for business apps accessing sales data, managing expenses, collaborating on projects, all from your phone or tablet. One thing to remember is they're often platform-specific. An iOS app won't run on Android, which adds another layer of complexity for IT departments supporting BYOD. So if you step back and look at the big picture here, these software trends, they're fundamentally changing how IT services are built, delivered, and paid for. For you as a future IT professional, understanding these models, open source, web services, SaaS, the importance of SLAs, and the strategic thinking behind choosing them, it's not just helpful, it's absolutely essential for navigating the modern IT landscape.
Okay, so as this digital world gets more and more complex, managing the underlying IT infrastructure must get harder too. What are the big management challenges that our sources point out? How do companies navigate this?
Yeah, the complexity definitely ramps up the challenges. One of the biggest is just dealing with platform and infrastructure change. Technology evolves so fast. Predicting future needs is really tough. So building scalability into systems right from the start is critical. You need systems that can grow or shrink capacity easily without major disruption. And with all those mobile devices flooding the workplace, mobility device management, MDM software, has become essential. You need tools to track devices, enforce security policies, manage updates, wipe data remotely if a device is lost or stolen. It's table stakes now. And when you use cloud services or SaaS, the challenges shift to managing contracts, ensuring security compliance with third parties, and monitoring performance and response times defined in those SLAs we talked about.
And that constant change must raise fundamental questions about management and governance, right? Like, how much control should be centralized in the IT department versus how much autonomy do you give to business units or individual users? Is there a single right answer?
That's a classic dilemma, and Laudon are pretty clear. There are no absolute right or wrong answers. It really depends on the organization, its size, its culture, its industry, its strategy. Some need tight central control for security and standardization. Others thrive on decentralized agility and innovation. So for you as a manager, it's about understanding your specific context and finding the right balance for your organization. It's a judgment call. Then there's a challenge of making wise infrastructure investments. It's not just about buying tech, it's about strategic investment. In today's world, especially with e-commerce and digital business, systems need to be available 24/7. Downtime means lost revenue, lost customers. So companies really have to think strategically about how they invest in infrastructure to ensure that reliability and performance. Failing to do so is a competitive disadvantage.
And calculating the real cost is tricky too, isn't it? The sources talk about total cost of ownership, TCO, being much more than just the sticker price of hardware and software. What else factors in?
Oh, absolutely. That's a critical point, often missed. TCO includes a lot more. Think about the cost of training employees to use the new systems, the cost of lost productivity when systems are down or when people are learning, the cost of network cabling, electricity, cooling, the ongoing costs of security measures, software licenses, support contracts. You have to look at the entire lifecycle cost, not just the initial purchase, to make truly informed decisions about value. Otherwise, you might pick something cheap up front that costs you way more in the long run. And to guide those big investment decisions, the sources suggest using a competitive forces model for IT infrastructure investment. It's a strategic framework. It involves looking outwards and inwards. First, understand the market demand for your firm's services. What do your customers expect? Second, analyze your own company's business strategy for the next, say, 5 years. IT has to support that strategy. Third, assess your current IT infrastructure, strategy, and costs over that same time frame. Where are the gaps? Fourth, figure out where your company sits on the technology adoption curve. Are you bleeding edge? Fast follower? Cautious?
And fifth, crucially, benchmark yourself. How do your IT service levels and spending compare to your direct competitors? Are you lagging? Are you overspending? It's not easy, especially with technology changing so fast, but doing this analysis helps ensure your IT investments are truly strategic and support competitiveness.
Yeah, that really drives it home. For anyone listening who's heading into IT service management, these aren't just theoretical models. These are the kinds of strategic questions and trade-offs you'll be dealing with day to day, making sure the IT infrastructure isn't just running, but is actually a source of competitive strength. That's really where the rubber meets the road. Well, this has been a fantastic deep dive. We've really unpacked IT infrastructure, seeing it not just as tech, but as this dynamic service-based foundation for the modern digital organization.
Yeah, and I think if there's one overarching point connecting it all is that the sheer speed of change means managing IT infrastructure is no longer just a technical job. It's deeply strategic. It demands continuous learning, adaptability, and a sharp focus on how technology drives business value and manages risk. It's a really exciting and challenging field to be in.
Absolutely. We really hope this discussion has given you some valuable, maybe some practical insights. If you found it helpful, please do engage with us, like, share, subscribe, and definitely keep the conversation going in the comments below. And to leave you with something to think about. As you look ahead, what do you personally see as the single biggest opportunity or maybe the biggest challenge for businesses trying to leverage cloud computing to really gain significant tangible value? We'd love to hear your thoughts on that one. Thanks for tuning in.